All right, unbelievably, we are at take 6. We're going to try to show you 2 quick demos of things people have been building in the app, and then we're going to build something ourselves in the app. So here we are in VR, and you can see there's this really cool rainbow shader. There's also this shader on here, which you can jump on to get teleported up, which creates kind of an interesting effect. There's these cubes that you can grab, and oh yeah, that's right, just click and hold. Nice. And then you can place them, and that's kind of a cool mechanic. And there's a little puzzle for you to solve. I'm not going to show you the puzzle because I haven't fully solved it. Notably, Nick, I wanted to let you know that I believe, so what he did is he went to one of the AIs and had it build him an FBX converter that allowed him to bring in 3D models, and I believe it's reverse the normals. So you might need to reverse the normals so that it's not looking inside out, although it does look really cool. He's also built this really cool triangle that bounces back and forth. You can check this out at github.com/iamnick/uplayground. That's Nick spelled in 1CK. But yeah, that's a really cool demo. We're going to now load up the Lexi Paint demo. Let's give that a second. Okay, here we are. And this is her latest little like playground. So here you can see you can paint on the ground. You've got these little blocks that you can click on to change the color of, and they rotate. And then you can parkour your way to the top, and it randomly generates every time. So sometimes it works better than others. There's this little like demo where it rotates and moves over time at the beginning, which we missed. And I was going to note here that the ground is tinted. So these colors are not painting the texture correctly. What you'll want to do, Lexi, is change the color of the ground to be white again, or just don't change the color of it. And then change the texture. So like dump bucket, basically the texture, so that it is the color that you want for the ocean. Very cool, great stuff. We're gonna close the VM, we're gonna fall through the world, restart here. And it's time for us to create our own little app. Oh my gosh, we've made it. We made it through the demo section. That's usually where I get stuck. So we're on a roll. I'm very excited to build this thing with you today. I'm calling it Spawn. Whatever, I don't know what I'm calling it. I wrote it down. Where did I write it down? I have so many notes. Apparently not one with the name of this. So the idea is that we need to go to github.com/Yuu Online/Yuu This is where we start every project, or I recommend starting every project because it has all the defaults in it. And we're going to go ahead and fork this. So 3 dots, create a new fork. This fork is going to go under the Yuu Online, so you'll be able to, this might be a default game if we build it correctly. And I wanted to call it Yuu Block Placer, Yuu Stacker, because it's like a simple stacker game. So we're going to store that as Yuu Online/Yuu Stacker, and then we're going to call this Fun Stacking Minigame. All right, create fork. And so now you'll be able to, play around with this one if you'd like, just like we did with the other one. Here's our code, and we now can input this over here. So let's grab this URL, copy. Let's go to clone git repo, paste, insert. Let's go store that desktop. I have a git folder. Select as repository. Yes, I'd like to open it. There we are. Now let's open the hello world. We've also got the main running start from project name here, which is Yuu Stacker. And we're going to say save. We're going to hello world. And we're going to change this to hello video. All right, and save. So now that we got this all updated, we can now sync it. Going here, we're going to say quick comment updates to see that all is working in VR. All right, commit, sync changes. And now that that is synced, that is available for us to download. So we just need to grab Yuu Online/Yuu Stacker. So here we go, back into the Yuu Online app. And we want this to be an alpha because we're just constantly updating it. So adding alpha URL, github.com/Yuu Online /Yuu Stacker. All right, and create. All right, so there it is. We'll then click on it to download. There it goes. Now it's transpiling the files. And if we're lucky, that has worked. Hello video. Perfect. We're here. So now that that's done, we'll go ahead and close the VM. I'm going to go ahead and set my headset down, and it's time to discuss our plan of action. I can't believe this is going well. I'm literally on like take 6. So many things have gone wrong in the past. This is good. not with the Yuu app, really. It's anyway. So the first thing we need to do is spawn what I'm calling hover cubes. And the thing you need to know is that this build is inspired by the Snap Spectacles demo from AWE, where you would tap the block with your hand and then place it. And that demo was, for lack of better phrasing, very low latency / laggy. Like you would tap it and it would take almost a second to respond, and then you'd place it and it would take almost a second to respond. So we're going to build it much better. And we're building it inspired, so we don't have to do the same thing. We just want to make a fun single-player stacking game because, to be honest, I didn't get enough of it while I was there. And like I said, it wasn't perfectly fulfilling. Now, we are missing audio. We're planning to add audio features and all the sound effects and things that you need to make sound effects soon. We're not there, but we will be there soon. So we did this sticky note. So we need to spawn hover cubes. Ideally, I want them to like bob up and down. I want them to slowly spin. I want them to be a set of colors that are equally random and trigger with hand to follow. But we need to start by spawning them. So let's just start by spawning some cubes and then keep iterating from there. All right, so in our code, we have the hello world. We're going to rename this, and we're going to call this start game. And so the game's just going to start when you like open it. That seems like it'll be fine. Do you want it to last like 60 seconds? So we register start, we start, we have the in-world console. We're not going to use the in-world console, although we might want to leave it out in case we want to log things to the console to see if things are working correctly. We do want to spawn cubes, so let's call a new function, spawn hover cube. And part of me is thinking that these hover cubes should be a separate file. So let's go ahead and create a new file called spawn hover cube.ts. Don't forget the .ts, that's really important. And then what I wanted to show you is that you can type export constant spawn hover cube equals curly braces. And really, I do just want this to be a singular function. So we'll just create a function called function spawn and curly brace, and then we can put in spawn. And so theoretically, if we have other functions like despawn, other things, we can just like add them here. And now over here, instead of having spawn hover cube as a function, we can now just call something like function start new game, curly braces, and then we could do a number for like count, it should be a number. And we could also define count outside of this. So we could say constant count equals, let's say, some good number, 32. So we're gonna have 32 of these cubes, and then start new game will get called here. So we'll say start new game. And so theoretically we can call start new game after the game has been completed to start another new game, whereas we don't want start to happen more than once. We're gonna go ahead and say calling start new game. I mean, like, we're gonna have a console, we might as well use it, right? calling start new game. And then in start new game, we need a for loop. So we'll say for parentheses let I equal 0. And then while I is less than count, I plus plus. There we go. So now we can create these cubes, and we're going to call the spawn hover cube dot spawn. And we don't need to tell it anything because spawn hover cube as a file is going to be in charge of a lot of information. So we're going to start the new game. We're going to do this 32 times, and spawn hover cubes for now just needs to randomly place them. It would be good, so let's leave a comment here that says know where other blocks are so they don't overlap. Would be really important. So we'll come back to that. Under spawn, we're just going to start by doing something really simple to prove that it's working by using the spawn primitive dot cube. And we need a position, so we'll just do new vector3 parentheses math dot random times, and we'll do this maybe 8 wide, and then comma, we'll keep these at 1 meter high, and another math dot random times 8, which we really should like create a constant for this 8. So we'll call this constant. We'll call this diameter, and then diameter equals 8. And then we can use that command C, command V, command V. All right. Next up, we need to know the scale, which we're going to do a new vector3. I'm thinking 0.5. Let's create another value for this, call this scale. Set this to maybe 0.35 for now. And we can always change that really easily. So scale, scale, scale. And then our quaternion will be, actually, yeah, let's do quaternion, quaternion enter dot from Euler, because they're going to be randomly rotated. And then we'll say new vector3 parentheses 0 comma math dot random should be enough to give us random rotations, and then 0. And last, we need color, and we're going to just do color dot random hue for now. Alpha transparency, that's a good idea. Let's go with 0.75, so they're slightly transparent. Has collider, it's going to be false. There's no reason to jump on these or bump into them. You can just walk through them. And then it is animated, so we'll set it to animated. And there is no parent, so we'll leave that as undefined. All right, so we've now spawned cubes. One day we'll make spawning cubes so much easier. In fact, the plan is eventually you'll just do it in app. You won't do it from here if you don't want to. So we're done. We're gonna go create a comment on the commit, which is spawning 32 hover cubes. Press commit. Sync changes. There it goes. Done. All right. So now we can, yeah, looks done. Probably refresh that to see it update. Booyah. Now we'll head over here. Back in the app. We're going to go ahead and open up the Yuu stacker. It's got to go ahead and re-download and transpile those files. Ah, darn. I will sort that probably in a couple weeks, to be honest. I'm just like super busy right now. I have a suspicion I know what it is, but unfortunately just a wee bit too busy. I'm gonna go ahead and get Yuu stacker transpiled. There it goes. All right, calling start new game. And interesting. I forgot to center it on 0, 0. But look at that, we've got our cubes. Very nice. We do get a little bit of overlap here and there. It's not as bad as I would have expected, but it is definitely random, so theoretically this is gonna get worse. The location feels about right to be able to touch them. The size feels a little too big, so I think we go down to 0.25, and we center it. Maybe we go center in front. Let's move the console behind us and rotate it. Yeah, let's make a few changes here. So first things first, we're going to main. We're going to, sorry, we don't need main. We're going to start game where we spawn the console, and in-world console is spawned at 1.5 up. We're going to do it 1.5 back. Is there an option for rotation? There is. We're going to do, I don't know what a negative quaternion is. I think we have to do, how would I do this? Can I do quaternion.look? Look from to. Calculates the forward and calls look at. We just need a forward and an up. Okay, look at, we need to pass in the forward, which is vector3 dot back, because we want it to look backwards. And then up is vector3 dot up. Okay, so that is reversed. And then I liked the idea of spawning the cubes in front of us. So we were using math.random on the left and right. So the first values are left and right. So we're going to change this to minus diameter divided by 2. So negative diameter divided by 2 plus math.random. Need another parentheses. Okay. Diameter divided by 2. Oh, I put it in the very wrong spot. Command Z, Command Z, Command Z. Let's just try that again. Right here, parentheses, parentheses, plus, and then say negative diameter. I just realized we could actually use minus, couldn't we? So we do math.random, and then wrap this in parentheses, then subtract, put another parentheses here, and then subtract, parentheses, parentheses. We need diameter divided by 2. There we go. Shift-Alt-F. And I don't like that we're calculating diameter twice, so we're just going to go ahead and say radius equals diameter divided by 2. And this is over-optimizing, but why not? Okay, so we subtract radius to give us left and right. Now we want the forward to be negative what it currently is, because it's currently behind us. So if we just change this from being times diameter to times negative diameter, it's now in the correct direction. So we're going to go ahead and say moved console and cubes to better positions. Commit. Sync changes. And then we'll go back over here and try it out. Click. Loading use stacker. So if you are new to the Yuu Online app, and if you haven't, go to yuuu.onl/alpha. You can sign up. And the thing you should know is when in the current iteration, when you see headlock, it's because we have to fix that. It's a really easy fix. I just haven't had the time to work on it. But anytime we download a file from the internet, we get headlock because I'm just not doing it async yet. All right, so the blocks spawn perfectly in front of us. We turn around. The rotation is backwards, so I don't know, just reverse it. So here we'd said look at back, look towards vector3.back, look towards vector3.forward. I'm not sure why that's correct. Look at, is this looking at a position? Yeah, no, it says it's a forward. If you look at the forward, I don't know why I have that backwards. But I'm pretty sure if I go to the UAPI vector3 basic types, vector3, and we go down to forward, here it is. Forward is -1. Yeah, that's correct. And back is +1. I am not entirely sure. I guess it could be that our quaternion is designed to work with the correct values. It is possible that our quaternion is reversed. I mean, we do eventually want to fix everything to actually use the correct forward, or what I consider the correct forward. For whatever reason, Godot has the reversed forward. Look at, right? Cross up. But you know what? I think it is right because it's looking at the back. Yeah, no, I think it is right. I think it's just kind of confusing when you think about it because like it itself was looking backwards, but I need it to look forwards, which allows me to look at it backwards. That is confusing. But anyway, I've got it. Flipped console correct way. Commit, sync changes. Crazy little update to have to... You don't have to test it, right? But like, it's better to take these small little tiny steps. All right. And then... am I crazy? Oh, the console is now on the ground. What are you doing down there, sir? But hey, you can see the overlap. This is what I was worried about happening. And so we're going to have to use a grid to place those randomly. And there's a pretty easy way to do that, I think. I'm actually not sure if it's easy. Why is it in the ground? 1.5, 1.5. Position seems right. I don't know why it was in the ground. I'm going to assume that this is a weird on start placement bug or just something else went wrong. We're going to ignore that for now. We'll try it again in the next update. Know where other blocks are so they don't overlap. Let's start there. So let's remove this overlap. To do that, we need to know which spaces are occupied. And there's a lot of different ways to do this. I like random. I'm like even okay with them bunching up. So rather than trying to like evenly space them, which would be one option, I think what I want to do is just say constant. We're going to call this, I want it to be a map, I think, right? Yeah, that's a good idea. Constant. Do I? So we're going to say grid grid positions occupied equals new. I don't know if I want to use a map. I'm going to use a string array. We'll just do array, and then we'll say this is a of type string array. Okay. And then we're going to need a new function to clear this out. So we're going to say function empty grid. And so empty grid is interesting. There's a few different ways we can empty the grid. We can empty the grid by simply saying grid positions occupied dot length equals 0. That's one way to do it, but it still means all the cubes exist. So I think when we empty the grid, what we want to do is actually go grid positions occupied. And I think what we want to do is actually, instead of this function that we really want to call is clear previous blocks. That's what we really want to do. So in addition to this, we need an array of entities. So an entity array called cubes. All right. So we got our cubes. We're going to clear previous blocks by saying cubes dot for each parentheses arrow function curly brace semicolon. So now for each of these, we're going to say, oh, we need to know the cube. We can then say cube dot destroy. That will destroy the cube. So we can now create a function which we'll put above spawn called clear previous blocks. And now that's going to go through and destroy all the cubes, and then it's going to empty this grid because theoretically there's no more cubes left. So down here we need a cube, so we say constant cube equals. So when we spawn the primitive, it returns the cube. You can hover over that to see that it returns an entity. Then we can say cubes dot push parentheses, and now we're going to push in the cube. Okay, so now we got an array of cubes. We need to clear this array anytime we start a new game. So when we call start a new game, before we spawn cubes, we need to call spawn hover cube dot clear previous blocks. And that makes me realize I want to rename this file. So let's right click, go back over here, close down the Yuu API, and spawn hover cube we're going to rename as just hover cubes. So it's a little bit clearer what this file is all about. So we've got our hover cubes, and yes, that's going to update our imports for us. Press save. Then we're going to go ahead and rename this. Right click, rename symbol to hover cubes. There we go. And so we're going to spawn. We've got clear previous blocks, which we're now calling cubes. So let's right click, rename symbol to clear previous cubes. I like the idea of using the name from the function we're calling, which is destroy. So destroy previous cubes. That makes sense. So we destroy the previous cubes. For each cube, we destroy it. Grid positions occupied dot length equals 0. We have spawn. So hover cubes dot spawn. That makes sense. Press save. Come back over here, and we can see that it renamed the symbol for us. So this all looks good. And clear previous blocks is now destroy previous blocks. We need to delete this. Command C, Command save, back over here, Command V, Command save. All right, so we renamed some things, and on start game we're destroying. And now we have this grid positions. Now to utilize this, the reason I chose string is because it's really easy to check an array if there's a string inside of it that matches. And so we need to turn this location into a grid synced amount. I also suggested that the scale should go down to 0.25. And let's imagine the grid is 0.35. And so we had this diameter. We're now going to change this into grid space diameter, which is going to be 0.35. So just slightly larger than the scale of a block. We're then going to need to know the number of spaces. So we'll call this the radius of tiles, which we had as 8 before. Let's go to 6. So it's slightly further out. Well, these are smaller. They're a ton smaller. There's like 3 for each. So 3 times 4 is 12. Let's go to 10. So it goes 10 to the left, 10 to the right. So it's like a 20 by 20 grid. So now we need to determine the x, so constant x coordinate, which is going to be equal to math.random times radius of tiles. So we got the radius of tiles, and so radius of tiles is not like a terrible name. Number of tiles wide. Now I can make this 16, which feels kind of cool. Command C. So then we take this, wrap it in parentheses, add a semicolon at the end if you like semicolons, and then you use math dot floor. Okay, so this is going to return values from 0 to 15. Let's make this 17 so we get the 16 value, so we have it even from left to right. And then we need to subtract 8, number of tiles wide. What's the easiest way of doing this? We say number of tiles outwards, change that to 8, Command C, parentheses, times 2 plus 1. I like extra parentheses, so I'm going to add another pair here. Okay, and this is number of tiles outwards. Okay, so we take 8 times 2 is 16 plus 1 is 17. Then we need to take negative number of tiles outwards plus this. Of course, we could do just subtract that on the end, which is what we did before, so we might as well do that here. Okay, so we subtract the number of tiles outwards, and that's going to give us a value ranging from 0 to through 16 for our x-coordinate. From negative 8 to positive 8 through positive 8. Okay, so that's our x-coordinate. And then constant our y-coordinate is simply equal to 1. And constant our z-coordinate is a little bit more complicated, but it's really not too much further off than this. It's really just this, Command C, and since it's always positive, we don't need to multiply by 2. We do need to add 1, so we can remove that and that. So we take math.random times number of tiles outwards plus 1, so now it ranges from 0 through 8 out. So we've got an 8 by 17-ish grid. Okay. Now that we got our x, y, and z coordinate, we need to convert this into a position. So we'll say constant position equals, and we need to say new vector 3 parentheses. It's a lot of work to get this. Sorry, I said this was easy. X coordinate times the grid space diameter. So that's going to convert it to the relative spacing. And then the y coordinate is just going to be y coordinate. We're going to keep that as 1. And then our z coordinate is also going to be multiplied by grid space diameter. Grid space diameter. There we go. So now we got our position. And now our key, so our constant key equals, and then we say constant key equals x coordinate dot toString plus y coordinate dot toString. There's no way those two are ever the same, right? 1, 1 maybe turns into 11, but that doesn't equal anything. 1, 11 could be 11, 1. Let's add a centerpiece to make sure that these are always the same. So in the center, we'll put in a upward slash so that there's never a matching key just because numbers. So now this next step is where things get a wee bit more complicated. So we need to check, you have to say while, parentheses, the key is not included in the array. So we say grid positions occupied dot includes key. So while the grid positions occupied includes the key, we need to keep doing this. And so the y coordinates is a constant, but the x and z coordinates need to constantly change. And so does the position. The position can be determined after we're done, so we can move that to the bottom here. That's not really used until afterwards. Then we'll move this down. So we got x, z, and the key, which are constantly changing until we get the right one. So let's see. There's one other thing we need to do, which is say let I equal 0, because we don't want this to go to infinity. And then we're going to say, while it includes the key, and I is less than 64. We're going to try 64 tries. So then we'll say I plus plus. So if it includes the key and I is less than 64, we need to keep trying again. And I suppose what we can do is do this once up here. This is a little not what I'd recommend doing. Change this to a let. change this to a let, change this to a let. I'm not exactly sure like the way that I'd really want to do this, but since I'm kind of crunching here, I'm just gonna do it this way. We can now remove the let from these. So then we get random x, z coordinates to create a new key. And then once that's done, we can create the position. The key will have been updated. And now that we have our position, we can now say grid positions occupied dot push the key in. There we go. And then we'll move this up and this down. And then right here where we were previously creating the position, we'll replace that with position. All right, we're finally done. Man, that was a lot of work, but they should no longer overlap, which is pretty great. So back to sync, and we'll say added grid positions to prevent cube overlap. Commit. Save changes. All right. Headset on. Running back over here. Casting is stopped. Let's get that working. Okay. Let's go. Come on, buttons. Oh, my boundary disappeared. You gonna work for me? Confirm boundary. Press this button. Press this button. Cast. Cast to web. Next. All right, here it goes. Looks like it's loading up. Perfect. All right, here we are. Let's go ahead and close the virtual machine and reopen UStacker. Okay. So we clearly have an overlap here, but nowhere else. So what? Oh, we got two overlaps. Little bits of flicker there, just FYI. Console is still in the ground, and these positions are definitely off. Let me jump off the world to see where things have loaded. Okay. So are they just in the wrong? I think I forgot to make them negative. That's still at 0, 0 for some reason. So something's clearly wrong. I'm not sure when this froze on you. Let's see. I hope it worked. Does vector 3.forward somehow break this? And why? Let's try quaternion.1. Let's try seeing, did I forget the negative on this? Negative z chord. So that would be forward, yep. Okay. The overlap was weird. Is it possible that we had matches over 64 times? Let's go to 256. Seems strange, but not impossible, especially with this few of tiles and 32 being spawned into them. Let's create more space and spaces. Let's go to 12 tiles outward. Let's go to space here of 4, 5. And we'll just say added more spaces to grid. And that's basically it. Commit. Save changes. There we go. Oh man. I don't know why the casting is just really not liking us today. This worked so much better last time. Let's go try that again. Cast to web. Yeah. Okay. We are now casting. Should appear any second. Perfect. Go ahead and load this again. Okay. They spawned further apart. We still got overlap. That is perplexing to say the least. This is still facing the wrong direction. I'm not sure if I care at this point. What is going on with these? I think we need to know what's happening with our iterator. Like, there's no chance. There's no chance that I ever gets very high. So let's go to... Oh, I is never reset. I is never reset. I isn't reset. Wait, no, that makes, because it resets every time you load the function. Never mind. Spawn the function, sets it to 0. Never mind. What the heck is going on here? All right. Console.log. This is what console.log is for. Log I. Save. Added debug to figure out y. Doubling up. Commit. Sync changes. Please stay online. Hey, it did this time. All right. Open, reload. Okay, so this time we had no doubles, but we do have all the notes here. So you can see I got 1, 1, 3, 2, 2, 13, 19, 2 of 56. Lots of 256s. Clearly that doesn't make any sense. So, and obviously they didn't place. Like, there's no doubled up ones here. So what is happening? Why are they getting to 256 all of a sudden? What is happening? X coordinate plus Y coordinate dot toString. Oh, I'm an idiot. I'm an idiot. We forgot to recalculate the key. No, we didn't. No, we didn't. What am I talking about? The key is fine. What's going on here? Oh, we're using the Y coordinate. We're supposed to use the Z coordinate. Duh. Okay, it all makes sense now. Okay, got it. Got it. We found the bug. So we'll say found and fixed bug with key. I was like, why is the color different? It was the color that showed me what was going on. X and Z. Commit. Save all and commit changes. Sync changes. There we go. And I mean, these are looking pretty good. Let's go ahead and reload it. I guess we can leave that console there for now. It's honestly not in a bad position, actually. So yeah, that looks good. We got little bunches here and there. It's a nice spread out. And now we need like a podium up here to place them on. But we also need to be able to grab them, which is a whole mechanic in and of itself we have to build. But I also want the colors to be a fixed set of colors so that you can kind of like have fun with the colors. And the easiest way to do that, I think, is going to be to build an array. So let's see. We got destroy previous cubes. Let's create an option to set the theme. So let's create function. Let's do 2 spaces. Function set theme. Theme. I feel like I spelled theme wrong. It just looks weird to me. And so we're going to call this the base color, which will be a color. And then we will have a option Boolean called isRainbow, which will be a Boolean. And then we need a series of colors. So we're going to say constant colors is a color array, which equals an empty array. And then set theme is going to say colors.length equals 0. That clears it out. Then we're going to say if isRainbow, we can then the idea of a base color is that we can plus and minus a couple colors. Let's try something here. This could be interesting. So we'll call this the theme, and the theme can be of type color or the string rainbow. And then we can say if theme triple equals rainbow, then we do this, else we do that. Okay, there we go. So that's a lot more straightforward. So for our rainbow theme, I want to do, let's see, Roy G. Biv. Red, orange, yellow, green, blue, indigo, and violet. Red, orange, yellow, green, blue, purple is usually the set that I go with. That's 6 colors. I feel like 6 colors is a lot, but it does hit all the basics. So let's go ahead and do that. So we're just going to say colors.push, and we're going to do some math to make this. Oh, math is not the way to do it though. Colors.push, because we might want to refine the color a little bit. So we're going to just have block colors. So we can have, in fact, there's actually some built-in ones, color.red, and then we can modify these later if we want better ones. Red, orange. We don't have orange built in? Hold up. Hold up. We don't have orange built in? I better go put that on my to-do list. Feature, add orange to default colors. It's like actually such a simple color. And then maybe a note in here that says, are we missing any others? Question mark. Okay. So we're gonna need new color parentheses. So red is 100% red, orange is 100% red, 50% green, 0 blue, red, orange, yellow. We do have yellow, red, orange, yellow, green, blue, and do we have a built-in purple? We do not. So we're also missing purple. New color parentheses. And similarly, this one can also be created by just mixing 0.5 red, 0 green, and 1 blue. Okay, so these are like really hard colors. These are not the colors that I would normally choose. I would definitely make up like softer, kind of more pastel-y colors for this, but for now, this is a good starting point. And then else, because apparently we just want to have fun with this theme thing. And we also need to export the set theme. Let's go ahead and put that up here. Set theme. So on start game, we can call theme, which will be a color or rainbow. And then right here at the beginning, we can call hovercubes.setTheme to theme. And for now, we're going to start by using rainbow. So we're going to go ahead and pass in single text rainbow. All right, sorry, Nolly wanted some attention. Sorry, where did we live off? Okay, so we were calling rainbow by default. That makes sense. We can try the other themes later. And so the idea is here, we would take the color that they picked and then build a theme around it. And so we could say colors dot push. First of all, we need to push in the theme color, the theme, and then we need to take that color and convert it to a hue. So we say constant hue equals, and then we call color dot to hue, color to. Do we not have a way to convert it to HSV from HSV? We don't have a to HSV. We don't have a to HSV yet. Just like double checking. Oh, we do have magenta in here. I don't think we have to HSV. All right, let's make a comment about that. Also missing to HSV. So in the meantime, we can go, yo, chat, can you make me a 2HSV function in TypeScript? This is the easiest. All right. It's so much work, isn't it? Example, my values range from 0 to 1. Okay. Here we go. HSV function to HSV. I think that is pretty much copy pastable. So for now, because we're in a rush, and we should have had this already in here, I'm just going to paste it at the bottom. We have 2HSV, which is going to return a vector 3, I think is the way to go. So you're going to take in a color. So potentially by the time you're watching this, we've already got a color. And then unfortunately, we got to type this out, color dot, and then copy paste a million times. Command C, Command V, Command V, Command V, Command V, Command V. Good. Command V, Command V, Command V, Command V, Command V, Command V. And then I just gotta hope that the AI did a good job. All right, and then we need to say new vector 3 parentheses h comma s comma v. All right, perfect. And now that that is done, we're gonna go over here and say hue is 2HSV parentheses the theme and then dot x, because the x is the hue. So now that we have the hue, we can now modify it and create more colors. So we can say colors dot push parentheses, and we're going to take new color parentheses. So we need to actually do color dot from HSV, and we're going to type in hue for now, and then saturation will be 1, value will be 1. And the trick here is, no, there's no new, is that the hue is a value ranging from 0 to 1. So if we say parentheses around it, we then add to it, then we modulus 1 at the end to keep it within 0 to 1. We can now add several different values, like 0 plus 0.5, actually 0.05, excuse me. And then Command C, Command V, Shift Alt F to make that pretty. And then we can add 9.5. So now we got 3 color values, and we need a couple more. And so I'm going to go Command C, Command V, 0.9, Command C, Command V. We'll go up to 1. So now we've got 5 values, and we need 1 more to really move this. And I think we're just going to go forward to 1.5. So those are our 6 colors. So if you threw in, let's say, let's see a hue slider and then images. So if we look at a nice hue slider like this one, and then we recognize if we threw in like 0.5, we're going to go 0.15 forward and 0.1 backwards. So 0.5 right here is going to give us 0.15. So it's going to give us these 3 shades of blue here, as well as a couple shades of green here, which I think is pretty cool. So you get like this band of colors. I think it's close enough. It's not the best thing in the world, but it's pretty good. So now we've got it. Now let's use those colors. And I had a comment up here, which is now going to be changed to say, need to use equal, no, actually we can do this right off the bat. This is pretty easy. So what we need to know is the color index. So we can say constant, or no, let color index equal 0. And so when we set theme, we're going to say color index is set back to 0. Then Shift Alt F. This is all good. Now when we come up here and we need the color, and we're responding to primitive, we need to see that the color index moves forward. and we'll move the color index forward afterwards. So we'll say color index equals parentheses color index plus 1 modulus colors dot length. There we go. Shift Alt F, maybe add a space, and then come up here where we have the color and replace this with colors, square brackets, color index. And that will make sure we have equal numbers of each color, or at least like as close to equal based on the number 6 divided by 32. All right, so we have color themes and color themes. Commit, sync changes. Alrighty. Hey, it stayed online this time. That's good to see. Love to see that. It heard me before. It was like, I'm sorry. I just didn't know you were coming back. Says my VR headset. All right. Yo, okay, rainbow. Looks pretty good. Is this red, orange, yellow? Is this right? Let's count. We got 2, 3, 6 red blocks, 4. Yeah, they're definitely right. 5 purple blocks, 5 blue blocks, 4, 6 orange blocks, 4, 5 yellow blocks, 4, 5 green blocks. Nice. That's pretty good. All right, let's give it a theme, because I'm not gonna lie to you, this feels like it's missing pink. We can add one more color, right? We need magenta. It needs magenta real bad. So let's go back to our colors and go Command C, Command V, change this to color.magenta, and then down here we'll go Command C, Command V, 8.5, save. Added magenta to rainbow and commit, sync changes. All right. Here we go. It just didn't feel like a rainbow to me. Does it feel more like a rainbow? I don't know. What's wrong with this? Is it just because they're not oriented like rainbow? Maybe it's because they're not oriented like rainbow. But they're pretty good. It's not bad. It's like, all right, 2, 4 magenta, 1, 2, 3, 4 purple, 4 blue. That's good. We could definitely do more blocks though. Maybe we should just do 64 blocks. Would that be enough to make it better? So we say count goes to 64, press save. Increased number of cubes to 64, commit, sync changes. And then let's go ahead and flip you guys over, turn this on. All right, so while that's running, we're gonna come over here and we're gonna change this from rainbow and use new color parentheses 0.5, 0, 1, save. I'll commit that in a second. Okay, so here we are, and the new version has more blocks. So we have, wait, this looks the same. Excuse me. Count is 64. I is less than count. I plus plus spawn. Trying theme. All right. Commit. Sync changes. Did I miss a step somehow? It's possible. It's possible I went too fast, I suppose. I'm not really sure. Try this again. So we should see 8 of each cube. Ooh, we got our theme. The colors are off, aren't they? I mean, it's a cool theme, but isn't it supposed to be shades of blue? Because I went purple, so it should have gone to magenta, not yellow and orange. I mean, I like it. It's great, but what happened to my colors? Did I do the math wrong somehow? I mean, it looks great, honestly. It's like actually pretty cool. It looks like one side definitely went forward. So our forward went forward, but then our backwards went too far back and grabbed yellows and oranges. It looks good though. The number of counts, right? Okay, so this is hard because the shades are so similar. I see 2, 4, 6, 8 orange. Yep. 2, 4. I mean, there's like 2 shades of orange right here. Like, got this yellow kind of gold color. Yeah, that's definitely a different shade of gold. Are they almost too similar? Should we make a little bit more distance? Let's see. Maybe that's a good thing. I'm not sure. Like, there's the point of a theme. So we put our theme in, which then gets converted to a hue, which we assume is 0 to 1. And based on what we're seeing, it does seem like it's 0 to 1. What did I do wrong? Plus 0.95. Modulus 1. Should have looped it back. Plus 0.5, plus 1, and plus 0.15. Those seem to work. Like, actually feeling really confused by this. I just want to do hover over. Hue ranges from 0 to 1. Console.log hue. Am I missing something about like order of operations? But the parentheses are there. Oh, I didn't think about adjusting the saturation and value. So we could go to like the middle step here, which actually there's a middle step here and here, and take the value to like 0.75 and then 0.75 and then do the same thing on this middle step, 0.75, and then this final step, 0.75. And then that creates 4 dark values and 3 bright values. That's an interesting option. Console.log hue. Theme uses darker shades for mid steps. Commit. Sync one changes. I mean, it's possible that from HSV or to HSV is wrong, but really not sure. I'm really not sure. Okay, there we go. Okay, so we got the same colors. They are definitely darker shades in here, which I like. Definitely feels like it's easier to pick them out. Like the dark orange, right? Looks good. Get the bright yellow. These two still feel pretty close. All right, what did our console say? Console says, wait, 207. I see what's happening here. I see what's happening here. So we're getting, this is where our orange and yellow values are coming from. This is where our correct values are coming from. The problem is hue needs to be divided by 365. So when we return, these probably all need to be divided by 365. Look at hue multiplied by 60 times equals 60, which should actually be divide by equals 6. Knew I shouldn't trust AI. H divide equals 6. If less than 0, add 360. If less than 0, add 1. There we go. but I assume saturation and value are also set up the same way, but I don't see them being multiplied. Saturation equals 0. This equals delta divided by max. Delta mod 6. I think we might need to console.log this to HSV. Command C. Save. Debugging to HSV. Commit. All right. So now that this is correct, the hue at least I believe is correct. So we should get the blue colors we're expecting. Dang. Let's try that again. Yuu Online. Loading. Open up Yuu Stacker. All right. Yeah, there's the colors we were expecting. That looks a lot better. The darker shades need to be like twice as dark though. And we can see the values. Okay, yeah, those are good. Those are good values. That's what we'd expect. So it was only the hue that was off. Okay. So with that, we can come back to here, remove the console log. We can take our 0.75, drop it to 0.5. So now our brightness on those is down. And let's see what else. I think it's time for us to make these things actually like follow your hand. So what we're gonna do is build a really quick and dirty hand follow script. So right here we've got cubes.pushCube, and once we push the cube into the array, we're gonna say cube.trigger.initialize, and then we need to know the radius. We know that our scale is 0.25, but we really want them to trigger pretty quickly. So I'm thinking like 0.45. Oh, there's a Y radius. Nice. Okay, so we can use their radius, which is 0.25. So we'll go with the scale. And then the Y radius we can set to be scale times 2. Scale times 2. So that way it's twice as high. Nice. All right. Shift Alt F, Command Save. And then we can say cube.trigger. And I need to remember what's in here. So we've got the occupied function. And we have the onUpdate function. So as long as your hand is above it, it should work. So the onUpdate function could be the way to go because it's really quick and dirty. There's definitely better ways to do this, but what we're gonna do for now, I think, could work nicely. So our onUpdate function has a payload. So let's go ahead and type in payload. I don't remember what's in the payload, so I'm just going to type payload dot to see that, oh, it has the positions. And positions dot, what's in positions? Positions is just an array of vector 3s. This must be the positions of the hands and things. So whatever's in the trigger. And what we want to do is follow right below the hand. So if you put your hand in, we want to move to right below. So we can then say cube dot position equals, and then we're going to say payload dot positions square brackets. We'll do the first one in the array, and then if we move to that position, it's just going to constantly flicker upwards, right? Well, not really, because the trigger surrounds it, so it's just going to move to where your hand is. That actually might be a really quick way to get this off the ground in testing. So we're going to say built quick follow hand script. Commit, sync changes. Okay. All right, loading this up. All right, Now we got our nice darker colors, and these all have triggers around them. So I'm just like checking to see how it's running, because I think this is the most triggers I've ever spawned. Let's go ahead and, whoa, okay. So I think it triggered on my body. I don't know if I can get out of it. Maybe if I go below the world. I think it's on me. Like, is it down there now? Yeah, it's down there. I don't know if we ever built specifically like hand only. But we'll fix this in a second. So, oh shoot, what are you doing there? Hello. Let's see, can I get my hand in this? Hey, there we go. Oh, that follows nice. Okay. And then I accidentally put it on my body. Well then, you know, I did say quick and dirty. Okay, so our positions, we really need to know if it's a left hand or right hand. So let's say let is right equal true. And then let's call cube dot trigger dot set occupied. So when it's first occupied, there's a payload as well. Arrow function, curly brace, semicolon. And if we say if, and then we need to get the right hand position, so we'll say constant right hand position equals, and then we call player dot right hand dot position dot get, and then if the right hand position dot distance to, ooh, this could potentially be undefined. Don't love that. Let's fix that. Let's say if right hand position, I guess that, what are we gonna do? Let's just question mark, vector 3 dot 0. There we go, there's no question here now. So if the right hand position dot distance to, and this is the distance to the payload dot position, so this is the position that's entered the trigger. If that distance is less than 0.25, then it's pretty clear that it was the right hand that triggered it. So we can say is right equals true. And realistically, we can actually say is right equals this right here. Command X, Command V. Now we can delete that. All right. So we got our occupied function. So when the trigger is first occupied, we set is right. Then when set on update function, we have the cube position, payload dot positions equals 0. But instead of using payload dot position equals 0, we can actually just use the right or left hand. So we'll say constant hand position equals, and then call player, ooh, we need the is right question mark player dot right hand. Sorry. Let's keep moving. Let's see. So we do player dot right hand dot position dot get, and then we're going to say that or player dot left hand dot position dot get, and then we're going to wrap this in parentheses, and just so we always have something, we're going to do question mark vector 3 dot 0. In fact, I might do vector 3 dot up, so that way if we get the wrong position, it's always in the center of the world and we can see it. And now we can say the cube position is now set to be the hand position. Perfect. It's kind of frustrating because we have the hand position stored in this array, and this is crossing the boundary to C++ to get this data. But it is only once per frame. It's not that bad. So we're going to say using handedness commit sync changes. All right, here we go. Head back to the app. Vidyuu stacker. Transpiling. All right, so here's our blocks. I'm gonna go ahead and reach out. Got it. Reach out. Got it. We got 2 blocks. Nice. Question is, can I outrun them? Can I outrun these? Like, I can if I jump off the world because I get teleported, but where'd they go? But yeah, and this is gonna potentially Z-rip. I'm gonna do it though. Yeah, sorry guys, if flicker warning. I just want to pick them all up because it's too much fun. Oh yeah, yeah, got them on both hands. Got them on both hands. Oh yeah, oh yeah. Oh wait, they're actually lagging enough that I can actually walk away from them. Oh, is it because I'm not looking at them? When I'm not looking at them, I can walk away, huh? I wonder what's up with that. I wouldn't have expected that. I wonder if my controller kind of flickers when you walk away, and then I can like pull my hand out of it, because it's definitely not lagging. Oh, or is it because I didn't pass it over because occupied didn't run again? Oh man, I'm gonna hit my desk if I'm not careful. I don't know how to do this. Okay, we're gonna stop there. Close VM. Nice. That was cool. That was really cool. Okay, I need to take a couple seconds to breathe, to drink. Oh my goodness. Progress. We're gonna make some of this stuff easier. Like, we're gonna build grabability in. Like, all that stuff is coming. You saw Nick built his own custom grab in place feature, which is really cool. But we're gonna have like actual grab in place and stuff eventually. It's like on our roadmap. It's hard to find time to do everything because there's just so much to do. So, so we've got the hover cubes spawning. We've got them, but they don't feel like they're magical. And I really want to create the magic of the cubes. So I want them to softly spin. I want them to bounce up and down. I want them to move to your hand and almost glide along with your hand. I don't want them to be on your hand. I want them to be below your hand, right? Like, you put your hand out, you grab it, and then it floats along with you. So this creates a little bit of latency. Like, I wouldn't use the word lag here because the Spectacles one was lag. This would be more like it starts going to you immediately using over time. And I think that is where we're going to go next. The app just keeps crashing. It's kind of cool that I can actually see into VR. I'm like rotating the headset on my desktop. So here we're using this hand position. We're using on update function. The reality is the moment the right hand is discovered on set occupied, we can use set empty to know if we're done. So we'll say let is occupied equal false. And then when is occupied, we say is occupied equals true. Okay. Then we don't use this. All right. And instead we create a function. So when occupied is received, we do need cube.trigger.empty function. So set empty function to be, there's no payload because it's empty, curly brace, semicolon, and then we set is occupied to equal false. Okay. And then we can say async dot set timeout parentheses arrow function curly brace, and we're going to do this 250 milliseconds. So 4 times per second seems like plenty. We're going to copy this code, Command C. We're going to paste it in here. Add some space between these curly braces. Shift Alt F. Okay. So the idea is this set timeout calls this set timeout. The problem is we need a function call is what we really need. What we really need is a function call. What is the way of doing this? What if we have an async ID? we wouldn't even need is occupied, but yeah, we don't need is occupied. So we need the async ID equals 0. And then here we see async ID equals async dot set interval, parentheses, parentheses, arrow function, curly brace. Now this is more like at 250 milliseconds. And now we can do the thing. And then here we call async dot clear timer, parentheses, async ID. Okay, so that stops the set interval from running. And so in set interval, we are going to, I actually deleted all the code we needed. We're actually kind of upset about that. Let's roll back a minute. Let's copy all the way through here. Command C, now Command Z. And I really needed that code. All right, so we're going to paste the new updated code there. We need to import async, so control period enter. Then down here, we've got this hand position. This is literally what goes into our set interval. So let's just move all of that into here. We can now delete the set on update function if we're not using it anymore. And then Q position equals hand position is not actually how we're going to do this. We're now going to call over time. Oops. Over time dot move to, and then parentheses, dot start, parentheses. And this is going to be for the cube entity, and it's going to move to the hand position over, we'll go with 350 milliseconds. In fact, I think I want to update this to be 100 milliseconds and this to be 200 milliseconds. So we can adjust those numbers to make it more or less snappy. We don't use the position setting. This now takes care of position setting for us. And there's an option to do rotation as well. Like we could Command C, Command V, call this hand rotation, and then say is right rotation, rotation, and then swap this with quaternion.1. And now our hand rotation is quaternion. And then we could do Command C, Command V, and do a rotate to, and then the hand rotation. And then this one, I feel like could rotate really slowly, like over 2 seconds. So it's just kind of slowly chasing after your hand's rotation, but never, it takes a long time to catch up at least. So we're going to say, and then the other thing that we need to note is this hand position needs to be below your hand. So we want to say hand position dot subtract in place, parentheses, new vector 3, parentheses 0, comma 0.25, comma 0. So that will move it below your hand. All right, so we're going to say block below hand and moves more magically. Okay, commit, save all changes, and commit, sync changes. There we go. Headset on, open up the app. All right, opening up Yuu Stacker. All right, here we are. So theoretically, whoa, okay. It is not moving because the trigger was rotated. Is that what happened? Because the rotation moved the trigger out of the trigger zone? That would make sense. So if I put my hand back in the trigger, it's now rotating to match my hand rotation. We need the hand, I see. We need the position. That's so fascinating. It's weird that it's not following the position of my hand though. Feels like it's missing something. That's so cool to be able to rotate that with your hand. It feels pretty cool. But I did want it to rotate only along the y-axis, not the other axes. But also, why is it not moving? Move to dot start. hand position, move the cube. Lexi literally just did a demo of this, both running at the same time. I'm gonna go check her code out. Head to, I think I have this GitHub. I was really hoping this would be a little easier. I have it memorized though. It's Lexi Roses 333. Oh, there it is. And inside of here, she has a little demo for me, which I assume. Where did she put this? Playground. Create paintable properties, cube, spawn interactive sculpture, spawn art studio, spawn moving cube. Here it is. Spawn moving cube is on line 167. Here it is. Spawn primitive cube, cube.position add, and then set timeout. So after 8 seconds, rotate 2 over time, and then move 2 over time. These appear to be the same. They have the same amount of time. They're in different order. What if order matters? That would be weird, but we'll try it. If we do rotate first, then move. Gotta figure out why that would be. Hand position should be correct. Hand position. Debugging move 2 over time not working. Commit, sync changes. I wonder if I hit commit and then sync changes too quickly, if that's part of the problem. Okay, so still not following my hand. Definitely rotating with my hand. Also land on it with my body and feet, and it still rotates with that. Run start has already been run. I don't think that's related. Let's see. It's possible that my commit didn't actually go through. We can check though by going to spawn hover cube, going to hover cubes, going to where is the cube function? Cube trigger are set occupied. Rotate 2 is now first. Yeah, so we have mimicked Lexi's code and it's still not working. All right, so hand rotation needs to be oriented only on the y-axis. I'm not entirely sure. I know what to do. Change this back to vector 3 dot forward. Change this to right hand dot forward dot get, left hand dot forward dot get. And interestingly, if we get the up, we take the forward and we apply it as the up. That doesn't work. Oh, forward dot subtract y. So this should be a vector 3. So we can say hand rotation dot y equals 0. Hand rotation dot normalize in place. And then hand rotation is actually now a quaternion dot look at parentheses. The forward is the hand rotation. We'll rename that symbol in a moment. And then vector 3 dot up. All right, it's been a minute since I've had to do that. Right click, rename symbol to hand forward. There we go. So we've got rotation should be better now. The motion not working is going to drive me a little bit nuts. Just for now, because it is pretty instant, we'll just say cube dot position equals hand position. I'm so perplexed why that's not working. Command slash, command save. That updates 10 times per second. Still not perfect. Rotation is now only on the Y axis. Commit. Sync changes. To be honest, I don't know if rotating the cube actually rotates the trigger. That was just kind of a guess I had made. I should do some more tests. You can also make the trigger visible. Ooh, that's nice. So as you walk around, it takes a couple seconds before it finishes, but it's interesting how the forward, because they're all randomly rotated, that's why they don't start. But they spin so fast at the beginning before they kind of like get slow. I kind of want to change the speed to be a little bit like what I'd call like a more magical speed. Also, the position is still not moving. That's bizarre. Why is the position not moving even when we're using cube.position equals? What? Close virtual machine. Like, seriously though, what? So, we didn't add the code here. Go back to UStacker. What the heck? We could try turning off the rotate too. Command slash, command slash, command slash, command save. And then we did want to make this like 5 seconds next time we actually run it. Is there a weird bug in our overtime that causes these two to compete somehow? I can't imagine how. It's possible that I missed something. So debugging motion not working. Commit sync changes. There goes nothing. Oops. Okay, so it's downloading and a little crash. Oh, okay, so the motion is working and it does do the, but yeah, you can also pull away because there's now that delay. Oh, that's nice. So you can kind of like let it go. Ooh, but you can't keep it if you run. Okay. So it's almost not snappy enough. That's so fun though. Definitely on the right track. I feel like there's definitely a mechanic where you want it to move this slow, so you can't let it go. But obviously that's not the case here. We want these to, and then they flicker if you do 2. So we need to prevent them from holding 2 at the same time on one, like only 1 on each hand. Right, gotta let go of this. Okay, Okay, so there's some thoughts. Let's set this down. There are some thoughts. Let's put down some notes. Sticky note. We need follow when running. We need only 1 in each hand. So like drop if new grabbed. So we got the triggering, that's in. We haven't put a stop, like a stacking location. Spawn hover cubes, that's done. But they don't bob up and down. They don't spin. We're having a weird issue. We got the colors array with equal random. We don't have a scoring yet. I'm almost thinking it'd be nice if you could drop them by like pulling your grab to let go. That feels like it'd be intuitive. Pull grab to let go. And I'm gonna take like 5 and then I'll be right back. So we're just gonna use that pause feature of OBS because we've been going. So it's a lot of problem solving. The follow with running, but all of it's kind of correlated. Right? So one thing we liked was that you could pull your hand out of the trigger to let go of it, but that doesn't allow you to run with it, right? Because that's the problem. But we are going to add the grab, pulling the grab button releases it. So that is pretty good. The second thing we can do is we can basically create a Boolean that says whether or not in fact, we don't even need a Boolean. We can say, what is the entity that's in the right hand or left hand? And it can be an entity or undefined. And then we only add an entity. Sorry, something in my teeth. And then we only add an entity if it's undefined, so therefore you can't register it to the hand. That seems like it will work really well, actually. Oh man, I was like so exhausted, like how am I ever going to solve this? I have no idea. But no, that should work. I'm kind of debating on the pull and grab to let go. It's a really fun idea. My concern is that if we add the bobbing up and down, we then have to make sure that when you let go of it, it goes back into the bobbing up and down. Although I suppose if we have an array of all the entities, we can see if it's not held, so it's not in left or right hand, and it's not in an array of stacked, then it can bob. And then we create a loop for the bobbing. That's it. We create a loop for the bobbing, and that same loop can be used for the following. Okay. It feels so straightforward. I have a salad in the fridge. I think I'm gonna go eat that, like watch a YouTube video, and then come back. I just need a like actual refresh, but like I'm glad we found a solution. Like that seems pretty solid. Okay, you see me when we're refreshed, and the light will probably be dimmer because the sun will have set, but that's okay. All right, and I'm back. Hey, the light doesn't look bad. It actually looks maybe even better. Whew, I feel good. Had some good orange chicken from Winco, if you know what that is. It's definitely so good. And a really nice salad. So, not entirely unhealthy. All right, I'm going to have to cast in a minute. Turn the headset to sleep mode. Let's see. I just want to double check that everything's looking good. We are recording. Audio's good. Good stuff. Okay, so the first thing we need to do is we need to think about how we're going to engage with this, which is going to require us to have a loop. Now this loop I would like to start at the beginning. And so what we're going to do is start this here. So we're going to type function start, and then we can register start. There we go. Now that we have our start function, we can create a loop. So we'll create a function called loop, and our loop is doesn't really care how much time is in the delay. So we can just type async.setInterval, parentheses, arrow function, curly brace, comma, and we're going to start with 100 milliseconds, but we can adjust that as needed to whatever we want it to be. And so we can try different things to get better aesthetics and whatnot. All right, so now that loop is being called 10 times per second, we can now say we have an array of cubes and we want them to bob up and down. So I think that might be where we start. Let's create some comments though. So we need bob up and down, rotate slowly. there's like the question of why is rotate not working when moving? Let's go to Claude and let's just see if it can give us any information. Add files, go to desktop, go to Git, go to UAPI, go to UAPI, go to motion over time, and I have this utility and I am getting a weird issue where sometimes I can't call rotate to and move to at the same time. I have also had issues with the raw entity dot position equals not working, so perhaps there is an error deeper under the hood. All right, so we'll let that think for a minute and see if there's anything obvious. Why is rotate not working when moving? We need to bob up and down, rotate slowly, and we're just going to go ahead and make this work. So we're going to say cubes dot for each, parenthesis, cube, arrow function, curly brace, and I want these to go off at random times. Now we know they're randomly placed, so it seems to reason that we could go through every other one, but we could also just say if math.random is greater than 0.9, so 1 out of every 10 times on average, it then starts a movement. And we know that it's supposed to center around plus or 1. So we'll just start with the bobbing up and down, and we'll say over time dot move to dot start, and the entity is the cube. The move to is the entity. We need to get the position, so we say constant position equals entity, just the cube, dot position, and then we'll say position dot y equals math dot random times 0.25, and then we'll start at 0.875 plus, and then wrap that in parentheses. So this will range from 0.875 to 1.125, and then we move to that position. And the duration, I think, is going to be 3 seconds. So it should be relatively slow bobbing. It's kind of very subtle up and down, and then it's random. So we'll just go ahead and say cubes bob up and down. And commit. Save all and commit changes. And sync. All right, let's get this set up again. You can even watch me turn my heads on it if you'd like. All right, headset. Let's go 3 dots. Let's see, where are you? 3 bars. Cast to web. Next. 3 fingers over. Wait for that to cast. Looks like it's casting. Apps. Yuu Online. Brilliant. Okay, so theoretically, they should bob, but they will fight with the hands, so we do need to fix that very much next. All right. Ooh. Nice. That's exactly what I wanted. It takes them all a little bit before they start moving, but once they're moving, it's It's a nice little thing. Sometimes they feel a little too fast, but then they're constantly like shifting. I mean, I'd almost say it's got the magic going for it. It's so close to being magical, but something about it is just off. I feel like they need to continuously go up and down, and the problem is they don't. They're just shifting randomly. So I've got some ideas on how to make this work smoother. The thought in my head though is, did Claude get any idea? Update functions obligate their interrelation behind instance of checks. I think you're wrong. If entity.position or entity.rotation doesn't return a true instance of those classes. Yeah, no, that's not a problem. The problem when you ask AI about a problem that it can't find the answer to is that it's just going to make us make stuff up and then try to tell you that it's very confidently correct. Concurrent move to, rotate to, likely an engine level transformation. Okay, see, like, this wasn't even related. Concurrent move to plus rotate to, likely an engine level transform issue. These completely separate arrays and separate loops. The logic here is correct. The problem you're describing, we're setting position rotation on the same entity in the same physics frame causes one to be dropped as a known pattern in engines that back entity transforms with a single transform matrix. Ah, okay, that actually makes sense. Now I see what's happening there. Okay, so that's not a bug we can fix today. I can get it fixed in the future. I know what to do. So physics process is overriding matrix when updating position and rotation at the same time. It doesn't explain why sometimes it works and sometimes it doesn't, but it does seem pretty accurate. We'll go ahead and grab a link to this chat so I can review it later, but that sounds right. So, all right. Good guess, Claude. I think you got it. Okay, so what we can do then, if that is correct, basically, just to kind of give you 2 cents here. When you call move to on the back end, it's updating the transform, but then you call rotate to and it updates the transform, but it's grabbing the current transform and then modifying it. But the current transform doesn't have the latest values because they're pasted at the end. At least that's what Claude's suggesting, which sounds right. So assuming that's correct, I just somehow need to make sure it's only updating the correct parts of the transform. I don't know if that's even possible. Like, that's for future me to fix. But what it means for us is that if we delay it by 1 frame, it would then work. So let's go ahead and add a 1 frame delay to our rotate to, which we had right here. So we're going to go ahead and delete this. We're going to consider this actually. Oopsie. If we use position equals hand position rather than the smooth motion, it might actually be, it won't mess with the trigger. Oh, but that we need to fix that anyway. Command Z. We need to fix the trigger anyway, it's fine. Command / okay, move this down. We need a 1 frame delay, and to do that, you just do async dot set timeout, parentheses, arrow function, curly brace, and you can type in a small number like 10. It'll wait till the next frame. And then alt arrow up, backspace, save. Okay. There's our move to. So we move to immediately, and then we rotate to slowly. And then up here, we can do the same thing. let's copy this, Command C. Let's go here, and when we're updating this position on our loop, we can also update rotation. It would probably be better to keep these out of sync. So let's create another math.random and add a curly brace, break it to move these up, Alt arrow up, backspace, backspace, Command save, okay. And then what we need to do is rotate to quaternion dot from Euler, and then new vector 3 parentheses 0 comma, and I believe if we hover from Euler, these are in radians, so we can just do math dot random times 2 times math dot pi. So it'll range from 0 to 2 pi, which is the full gamut of options, and then we'll comma 0, so it's only affecting the y-axis, and the delay on that is 5 seconds. We will go to 10 seconds, so it's really subtle. And then the thing here that I think will make this piece better is this delay becomes relative to whatever the previous y position is. So we say constant previous y equals position dot y. There we go. And now we've got our new y. And so we say 3000 is what it should take to go from the, to go 0.25, to go the full amount. Ooh, even better actually. We can just use math.random. That was perfect, Command X. So we'll call this random. This will be a lot easier. And then math.random. And then we'll put in random, and then up here we say random times 3000, and then just to make sure it's picture perfect, we'll do math.floor, so it's in solid milliseconds. Okay, so we've now got better bobbing and rotating commit. Sync changes. And here we go. All right, you guys ready to bob smoothly? They're like, we're gonna bob so fast. They're gonna bob so fast, guys. We need to make that number 6,000, not 3,000. Just realized. Super bobbers? Ooh, what are you guys doing? They're not moving up and down at all. Are they? The rotating is definitely happening. It's interesting because some of them did move, but they moved instantly. Is the delay not long enough? I did 10 milliseconds. Maybe that happened in the same frame. Okay, this does appear to be synced to my hand. I have a feeling 10 milliseconds was not long enough. So let's go to, and I wanted this to be 6,000, so we'll do that. Go to the delay, change this to be 50 millisecond delay, scroll down, change this one to 50 milliseconds, which should be about 2 frames. We can check that by taking 50 milliseconds, dividing it by 1,000 milliseconds in a second, and then multiplying that by 70 frames in a second, and that's 3.5 frames is what it should be delayed. So it should be like 4 frames delayed, but it's like imperceptible to human. So hopefully, so we'll say longer delay on rotate to commit and sync changes. Okay. It is interesting because sometimes it would work, but they moved so fast down. That was perplexing. All right. Reloading. And unfortunately the app crashed. Let's try that again. Here we go. Okay. part of me is like, are they moving but just so slowly I can't perceive it? But no, I don't think so. So it definitely, oh, right. I see what happened here. I wasn't thinking clearly. We're using motion over time. It doesn't matter how many seconds you delay. They're both being called on physics update by the motion over time utility. I'm a dummy. I don't know why I didn't think that through. Is there a way to fix this? Is there a way to fix this? Like, I'm thinking I could probably update the Yuu API, but like I think that's going to be the case. I think I'm going to have to fix the Yuu API for this to work properly. And so when it does work properly, we can just uncomment the code. And we're just going to say alt arrow up, delete, shift alt F, command slash, scroll back up, alt arrow up, command slash, delete. Okay, so now the motion will be working, which is, in my opinion, the most important piece. Save, and then say commented out rotation until Yuu API over time. Well, Yuu API C++ is side is fixed. Okay. Sync changes. Okay, so I think we got the rotate slowly, so that's good. All right, let's get this movement. Like, I feel like it could be even slower, perhaps, for the rotation. It's interesting that they kind of like instantly move down before they get the nice slow motion. That suggests to me that something is wrong with the calculation. Ah, yes, I can see what's wrong with it. Is it always when going down that's the problem? Yeah, it's always when going down that's the problem. I know what I did wrong, but cool. Okay, let's quickly fix this. So what I did wrong is we used random to determine how far we were moving, and that's not entirely true because we don't start at 0.875 in the beginning. Random is just determining the random position to go to. We'd still need to know the previous position. So let's switch this to being math.random again. Let's go back to the original plan. The original plan was better. I just thought I could hack it better. So say original or current y equals position.y, and then this is now the distance, which is up to, so we'll put in parentheses, we need to divide by 0.25 because that's the maximum distance it can move. And then we take the current y and we subtract the position.y, and we wrap this in parentheses, and then we do math.absolute value, so that makes a negative value positive, and then we'll say fixed timing on cube motion. Okay, commit, sync one change, try that again. And suddenly it looks correct. Nice. There's a nice, like, subtle feeling to it. It's not perfect, but it's good enough. Now, they do move with your hand still, which seems to override the other one because it's now calling move to twice on it, which is fine. If we let go, it'll bob back down to the previous y value. It just takes a long time to get there. Yeah, that's kind of cool. That is kind of cool. So what we need to know then is what cubes are stacked. We can remove this. We can move this for now. We can then need to know cubes. We need to know the stacked cubes. And what we need to do is say, when we're going through each cube, if not stacked cubes includes the cube, then we can keep going. So we grab these two and Alt arrow N, backspace, Shift Alt F just in case, save. Okay, so now we're only moving if it's not a stacked cube. We also don't want to move, so if not a stacked cube and the cube is not the left or right cube, so we'll say let left hand cube be of type entity or undefined, and let right hand cube be of type entity or undefined. And so then we say, and cube does not equal left hand cube, and cube does not equal right hand cube. So as long as it's not these cubes, we're good to go. Now in this loop, we do need to have left and right hand cubes follow hand. So we need to move that around. It also means if we scroll down here, we had our set occupied function, we had the isRight, and we now need to know on a left to right hand basis if it's right. So this is going to be a little bit not recommended, but we're just going to go for it anyway. Let left is right handed equals true, Command C, Command V, Alt, and then we'll use right. Oh wait, I just realized the cube is in the left hand or the right hand. Never mind, that's not relevant anymore. Okay, so we don't need the is right-handed because that's not relevant. We don't need the async ID because that's going to happen up above. We have the occupied function checking to see if they're right-handed. And then really we can now say if is right-handed, then place in right hand if not occupied, and then else / place in left if not occupied. Okay. And we had this set interval, which is really all stuff that's going to get moved up. So let's start by just saying if right hand cube triple equals undefined, then right hand cube equals cube. Okay, Command C, and then paste this here. Left hand cube equals cube. Delete this comment. And then we need to set the cube to undefined. So let's go ahead and copy these lines here. Command C. Come back to this in a minute. So this is going to set it. And then when it is empty, we have the setEmpty function. Do we not have a setEmpty function? There it is. SetEmpty function is going to say if right hand cube equals cube, then right hand cube equals undefined. Delete this and then Shift Alt F to make that pretty. I must have missed something. Delete this one probably, Shift Alt F. There we go. So if right hand cube triple equals cube, do that. If left hand cube equals cube, then left hand cube is set to undefined. All right, so that clears it out when the empty function is called. And then this async is really no longer this. It's now Command X, delete the async stuff. That's no longer relevant. Come back up here and then say if right hand cube is defined, we'll do this. And then if left hand cube is defined, do the same thing. Now we have to change this. So we can say hand position is the player's right hand position dot get question mark vector 3 dot up. Perfect. Move the parentheses. And we don't need the is right because we know it is right, so we can say the forward is the player's forward dot get, else it's the forward, and the cube is the right hand cube, and we'll paste that right to here as well, and Shift Alt F. Now I kind of feel like it might be easier to just copy and paste this down to here rather than trying to fix it all again. So paste, and then change this to be left hand, subtract in place, left hand cube, left hand cube, save. Cool. Okay, so now we have tracking, and we don't track if they are this. We're not trying to do two at the same time. So there's no overriding. There's clear following. There is no way to let go, which we might want to build, but let's first test it. So we're going to say new, better, and follow code in loop. Commit, sync changes. All right. Here goes nothing. New stacker. Okay. So currently we have, oh, is this already working? Was that, I closed my eyes for 2 seconds to like get hair out of my face. Let's wait a second. Oh yeah. Oh, but it doesn't. Oh, because the empty function is still emptying out the thing, right? We don't need to do that anymore. I mean, we could, but we don't want to. So that's not how we set it back to undefined. We're going to set it back to undefined. Sorry, I had like a thought in my head. I need to get back to it. We need to set undefined when think. When they place the block or when they pull their grab. Yep. I'm going to write down undefined on this. So the grab or place. Follow when running. We haven't fixed that yet. We will in a second. Only one in each hand. We've definitely done that. Drop if new grabbed. We're not doing that because that, but we will do the pull to let go. So I don't believe we've set up entity triggers. We have object detecting player triggers. We do not have an entity trigger. It is on my to-do list to build the API for entity triggers, basically by duplicating the player trigger one. They're very similar. But because we don't have that, the ability to detect when an object enters a trigger is not a thing yet. So we're going to build our own custom version of that today. If we had entity triggers, I'd build like a better platform stacking system. But because we don't have that, I'm going to build a really rudimentary singular platform to stack these on. Just a really quick, let's get the stacker thing working. And then later on, we can do more. I would like to come back to this. This is fun. We're building like an entire game mechanic, which is pretty cool. I'd like this to be a really like fun default game that you'll be able to play if you join the alpha. By the way, if you didn't hear already, go to yuu.onl/alpha to learn how to sign up and join this program. We are slowly accepting invites. I'm very excited. This is good progress, but I do think we're going to be wrapping here after we get the basic first platform stacking mechanic, which we're really close to. So let's go quickly fix these things. But I'd imagine like at some point in the future, if we continue working on this, we could have entity triggers. We could like replace and update the method to be better. We'll fix the rotation things so that they're a little more magical. We're going to add sound effects in the future. I don't know. This could be a 4-part series if we slowly work on it. This I think would be the longest episode, getting everything initially started. So anyway, if that's something you want to see, let me know. Because sometimes if I don't know, I'll just do it on my own and you won't get a video. So Just ask. Okay, so what we're going to do next is note the empty function is wrong. Delete. Okay. Now that that is correct, it does question whether or not this, I feel like this is fine, yeah. Okay. Yeah, getting tired, guys. This is approaching my bedtime. Not gonna lie. But over time, move to, you grab it, it follows you. Now it's gonna follow you permanently. So the next thing we needed to do was to pull to grab to let go. So we've got a register start. I don't remember how this works. I feel like this goes into start. It's been a minute since I've done this. If we call events, or is it controller? Controller.subscribe, and we need the button. So we're gonna do the left grip and the right grip, which is your grab. So right grip, we're gonna connect the, so you grab it, so you're holding it if you press it, and if you let go, so you release it. Released if you let go. And then the function that we're connecting will be this quick arrow function, curly brace. And then we're gonna Command C, Command V, change this to left grip. There we go. And then simply put, I think all we have to do to make it release is say, oh, you know what? There's a couple steps I want to do. Let's see if we can get this to work better. Because the trigger will automatically redetect, right? Maybe it won't because you're already in the trigger. You know what? It actually will work. Okay, it'll work. So what we do is we just simply say right hand cube equals undefined. And then this one is left hand cube equals undefined, because the trigger won't fire another trigger enter event because your hand's already in the trigger. There we go. So we're going to say added right and left grip let go feature. Okay, commit, syncing changes. Running back over here. Let's try this out. All right, we are in. Grab, got it. Clicking my grip, and it lets go. Nice. Grab, clicking let go. Oh, that's nice. That is really nice. So they got this kind of like snappy little thing. I feel like they could be a little bit faster to follow, but it's not too bad. Let go. The let go is nice, right? But yeah, this follow feature feels just a touch slow for some reason. I'm trying to figure out, punching stuff on my desk. Trying to figure out why. Why does that not feel... Let's see what the delays are on this. So you set it, and this loop is running every 10 milliseconds. If we change this to 50 milliseconds, change this to 0.95, this to 0.95, press save. The loop does this no matter what. Doubled loop. Let's change this to 100 milliseconds. Change this to 100 milliseconds. Just a lot snappier. Double loop to make block follow snappier. commit, sync changes. Okay. Come over and grab. Yeah, it feels snappier. It also seems like switch hands. Okay, grab it with my right. Oh, I see what it is. I see what it is. Oh, I see what it is. Okay. There's a small error in my logic right when defining it, where we say distance 2. What we want to know is if cube does not equal right-hand cube and cube does not equal left-hand cube, then do all these things. So if it is one of these things, we need to skip the cube because it was allowing it to be both hands. That's what was happening. Fixed bug with cube being applied to both hands. Commit. Sync changes. I've already grabbed one. Let go. All right, grabbing with the right hand, putting left hand in, letting go with right hand. Nothing happens. Perfect until I put my hand back in it. Letting go works. Grabbing works. Perfect. Okay, so we can now run around, try to grab 2. It doesn't let us grab 2. Grabbing with the other hand works. They're fast. They feel a little stuttery, which is kind of interesting. I'm not sure why they're feeling stuttery. Don't think they normally were stuttery. Could be just because they're moving too fast. Like 100 milliseconds is not a lot of frames to move across. I'm not really sure. Well, we'll probably look into that at some point. When I switched it from on update to on update physics, that made it not stuttery last time, so I'm not really sure. Okay, I'm letting go. Thinking it's time to build the stacking mechanic. All right, let's check the to-do list. And the to-do list says follow when running. That is done. Pull, grab to let go. That is done. Undefined on place, not done. Bob up and down, that's done. Slowly spin, that's done. Follow and stop at coordinate. Yes, so we're gonna use a coordinate to stop it, and then we're gonna add it to the stack. So we have the cube in our hand, and we need to know where to stop it. Now we've got our start function, so we can now create a pedestal. And so we're gonna say constant pedestal position equals, we could use 0, 0, 0, but I was thinking kind of like new vector 3, 0, comma 0.5, comma, yeah, 0, comma 0.5, comma, and then I want to put it 8 blocks ahead, maybe 10 blocks ahead, so it's right at the edge of the blocks. You're gonna have to run it forward, but it shows you where to go. And then we need to spawn a pedestal to put it on, so we say spawn primitive dot cube, and this cube is going to be at the pedestal position. That makes sense. The scale is going to be new vector 3 parentheses 0.5 comma 0.5 comma 0.5. That feels like it's probably still too big. We might go with like 0.35, 0.35, 0.35, because these cubes are only 0.25. Okay. And then quaternion dot 1, color is going to be color.white. Alpha transparency is going to be 0.9. Is that what we did when we spawned the cube? Spawn cube, spawn cube, spawn says spawn primitive with 0.75. Let's do 0.85. Just a little bit more solid. Has collider will be true. Base node type will be static because it's not moving. And the parent is undefined. All right. So we've got our pedestal. And now the trick is we need to know if the player's hand ever gets near the pedestal. And so we're just going to continue hacking as per usual. And so we've got our hand position here. So we're going to just say constant hand positions is an array of vector3 array. And that equals an empty array. And then hand position is determined. At the end of this, we will say hand positions dot push parentheses hand position. There we go. Command C, Command V. Move that down to the bottom of this one as well. Add some space, and at the very end of this, we say hand positions dot for each. There we go. Parentheses, parentheses. Arrow function, curly brace, and I am getting tired, guys. And then we'll call this the position. Double check that we're not using position. Just call this the hand position. That's safe. All right, so now this hand position needs to know if it's near the pedestal position without the Y. So we say constant direction equals hand position dot subtract the pedestal position. And then we want to remove the Y value. So we say direction dot Y equals 0. And then we say if the direction dot distance or magnitude, so like it's the length of the vector, if that is less than 0.25, we know that we need to stack it. And we can do that by knowing how many are in the stack, and we can do that by adding it to the stack. So when we're done, we need to know if it's the left or right hand. I see. We're gonna just hack this together by putting, this is not a vector3 array, but an array of vector3 comma Boolean. And then when we push it, we need to wrap it and then say true, it is right-handed, and then false, it is left-handed. So then we can say hand position, comma, is right, and this is a vector3, and this is a Boolean, perfect. And now we can say, okay, if direction dot magnitude is less than 0.25, then the constant, we can just, I guess we can just do this the old-fashioned way. If is right, which, and by old-fashioned I mean we're going to double up the code and not try to optimize it right now because my brain is just barely able to hold on here. So the magnitude is less than 0.25 and it's right, then the right-hand cube needs to be added to the cubes. So we say cubes, stacked cubes dot push right-hand cube. Okay. Stacked cubes is an entity array. Right-hand cube could potentially be undefined. So if you say if is right, then if right-hand cube, which it should be, but just in case we'll have this here, then we push the right-hand cube. We then want to move, so we need to say right-hand cube dot right-hand cube dot right-hand cube equals undefined. There we go. So now that the right-hand cube is undefined, the next time this comes through, it won't be moved. We then also need to stop it from moving. So we say over time dot move to, instead of using, we're gonna move this up and move this down. Instead of, because move to will cancel, you can read this, or I guess it's not in here, but it does cancel the previous move tos. So we're gonna move the right-hand cube to the new position, which is based on the number of cubes in this. And so we have the pedestal position, and we know that the pedestal is, ooh, I did the scale wrong on the pedestal. Let's get the scale right. So 0.5. Let's think about this pedestal being relative in size to the scale. So 0.25. If we make this pedestal position at 0.25, then we make the scale of it on the y-axis 0.5. It will then be half a meter up off the ground, and then each cube can be placed. So if it starts at 0.25, we add 0.25 plus 0.25. I know that sounds confusing. Basically, right, where were we? The place we need to move to is the pedestal position dot add parentheses new vector 3 parentheses 0, 0, 0, and then we'll fill this one out, which is the cube, what was it, radius? Width. Why is this not obvious to me? Number of tiles outward, grid space diameter, scale. We call it scale. So we take the scale and we multiply it by the stacked cubes dot length, and then we need to add to that with scale. So you start by going up by one scale. So it starts at 0.25, then you go up by 0.25. It's always got the cube in it already. So it's always at already 0.25 up. So now it's 0.5 up, which puts it, it needs to be scale divided by 2 so that it's centered. So wrap this in parentheses for consistency. And so, well, yeah, stacked cubes length up, and then 0.25 to get it, or it's actually really like 0.125. So 0.25, yeah, that works. Okay. So now those should stack onto the pedestal. What do we need after that? Probably the rotation, comma, quaternion dot, oh, no, you don't move to a rotation. Is that it? Does that all, it needs the duration. Why doesn't it tell me? Oh, I forgot to do move to dot start, my bad. And then the duration, which is going to be maybe 200 milliseconds, just slightly longer. Okay, so now that that is defined, so this adds it to the stacked cubes, this moves it, this sets it back to undefined so you can grab another. Then we need to copy and paste this for the left-hand cube. So we say left-hand cube, Command C, Command V, Command V, Command V, Shift-Alt-F, Command Save. And I think that actually works. So added stacking, commit, save changes. Fingers crossed this works. I think that's about all you're gonna get out of me today. All right, let's get that casting back up and online. Click the button, click the other button, click that button, click the cast button, click this button, press next, and there it goes. All right, now close this, open up your stacker, find the center of the world. So theoretically it's right out there. Ooh, you can't see it because it's white. Didn't think that through. But we still get to try it. So we got one. Ooh, nice. Okay, the rotation on that's kind of funky, but that'll do. I think that was just coincidence that they were the same. Yeah, that's just coincidence. Ooh. Oh, because you can still pick them up. We need to disable the trigger. Okay. The spacing between them feels like a little bit of spacing between them would be nicely magical. So there's that. The bottom pillar needs to be a little bit wider for sure. So let's make some changes. So let's see. This primitive cube will go up to 0.45 by 0.45. The color will be color.black. The transparency will go down to 6.5, so it's still super cool but not super solid. The placement needs to, when we're done with the right hand cube, we need to say right hand cube dot trigger dot delete, which I assume destroys the trigger. I hope that works. I'm not really sure, to be honest. Left hand cube. There's also, like, we could destroy the function, but I'm hoping that trigger dot delete, does it say what it does? No. I'll build those comments eventually, guys. Okay. Yeah, it's just when you write the code months ago, like literally months and months ago, kind of forget what it does, which is why we need better commenting. Lakes, get your work together. But it takes so much time, guys. It's so much work. Come on, think. So we delete the trigger. Don't have to worry about that happening because the trigger is now no longer functioning. Secondly, the spacing where we're placing it. We were taking scale divided by 2. That was fine. This needs to be wrapped in parentheses and then say scale plus 0.015. And then copy that, replace scale here, save. Okay. I kind of think I can do left hand cube dot rotation equals quaternion dot 1. No, we're not going to do this yet. And we can copy and paste this code and then comment it out. Shift Alt F, change this to quaternion dot 1. Then change this to 200 milliseconds. And then Command C, Command slash, Command V, right hand cube, Command slash, Command save. Okay. So made cubes trigger not work after being placed. Commit. Sync changes. And I think that's where I end for today. We get this working and we've done it. All right, transpiling, let's run over here. All right, new code's running. Okay, we got our new block. We got some cubes. Let's come and run over. Yeah, all right. There's our first one. Let's grab another one. Place it. Can't pick them up anymore, right? Nope. Nice. That delete definitely does what the name suggests it does. All right. Grab these two. Bring them over. Grab these two. Bring them over. The spacing isn't too bad. Be kind of nice if they kind of still had a little bit of a floating effect. I can't reach down that high or low. Nice. Can't tell if it's working. I know it's working, but I can't see them. They're not like, when I move, they're so slow behind me, which is really strange. I almost feel like we should definitely change that to be instantaneous. Or is it in part because as I get closer, it'll just go real quick? Oh no, they definitely aren't the right height. Yeah, okay, let's fix that. That is just, it needs to be on my hand. And it can't be like this slow magical thing if you're not looking at it. So the problem is this utility, the loop, is what's moving it. It's not like on update. So what we need to do is do an on update. That's pretty clear. So let's go down here and let's create function on update, parentheses, delta time, number, curly brace, and then we need to move hand position checks and all of this to every frame. Shift F, backspace. All right, so on update, we're gonna do the hand position stuff for the right hand cube. The loop is now just doing these, which we could send back to just being 0.9 and 0.9. And then the loop can now be called every 100 milliseconds. And then we need to say events dot on physics update is usually the best one to use. We got our delta time, arrow function, curly brace, call on update, parentheses, passing in delta time, semicolon, semicolon, shift alt F, command save. All right, so now on physics update is moving, and what we can do is say hand position, push, instead of using move to.start, we're going to just do right hand cube dot position equals hand position. And then command C, left hand cube equals position. And I think that'll do the trick. Okay, so cube follows hand exactly. Commit, sync changes. All right, here we go. Running over here. Let go. Okay, I was like, excuse you. Here we go. Nice. Oh, that's so much better. Like legit. That's so much better. That's exactly what you want to see. These things are a little low, the cubes, because like definitely they're getting stuck. Like I'm not grabbing them, so I'd move them up about 0.5 meters, so we should do that. And I feel like the distance between these could go down a little bit. So let's do those two things. Just tiny improvements right here. So we're going to change this to 0.05. And then we're going to change the placement position to the y. When we call spawn, y coordinate is going to get set to 1.5. And then when we're updating the y coordinate for the random loop stuff, we need to move that up by 0.5. So that's 375, 375, and the math looks good. All right, so moved cubes higher and closer together in the stack. Commit, sync changes. All right. So they should be 3 times closer. I'm gonna stand right here. We don't need to do so much wandering. But yeah, I have been hitting my desk, so okay, this might be too high, but also that's kind of perfect. Like, isn't it? Is it? What's happening there? That is so strange. It almost feels like I have to go above, which I don't think is how the triggers are supposed to work. That was weird. What is happening there? Okay, we seem to have some sort of weird bug with the triggers. The distance between is definitely nicer. It's a little more subtle. This is weird. I am gonna reset my... That didn't change anything. Didn't make it better or faster. Not entirely sure my controllers are the thing causing this to track. Oh, maybe, I don't know. So weird. Both controllers. Control. There's definitely something interesting happening there. This menu is supposed to be higher up, and I'm kind of wondering if it's related to that. Like maybe my controllers are way up here. Nope. I have no idea. And like sometimes it just works, so I'm actually perplexed here. Oh yeah, there you go. Pretty neat. Clearly there's some little bug here, and I'm not really sure what to do about it. What would I do if I had the brain power to think about working on it? I would do like a console.log of the position of things. I might also try to figure out which body part is causing the trigger. And yeah, that's pretty much it. I think I've got to run. But yeah, feel free to, if you have the Yuu Online alpha, feel free to go download this, try it out, try modifying it. The height of these is too high, clearly. It's actually really frustrating that it's not working, because I felt like it was working so much better just a second ago. Like, is it because they're moving? I'm not sure. There's so much to test, but we will come back to this. Look at the tower. Cool tower. All right. With that, I have to say goodbye. I will see you in the next one. Bye.